I've written the freehand placement tool. This allows the user to draw freehand what they like. Then I'll fit some Beziers to that 2D point input data. So we start off by collecting the points, the freehand points that the user has drawn, and then cleaning the points by removing coincident points, and then looking at the edges, the contiguous edges, and if the angle between edges is within a tolerance, we can consider them to be collinear, so we can remove those points as well. And then you could then pass your 2D points to the Bezier fitting code from the 1990 Graphics Gems article. The article, though, also suggests looking into your 2D array, into your array of 2D points for good corner candidates, and then splitting up your whole vector into a collection of smaller subvectors, and then passing those one at a time to the Bezier fitting code. So we need to find good corner candidates. We do this by having a look at two contiguous edges, and if the angle between them is, for instance, less than 50 degrees, you could consider that to be a sharp corner, and so you store that position as a corner candidate. That's one option. You can also configure the tool to automatically find the corners for you. I do this by having a look at all the angles between all the edges, having a look at the standard deviation, and then allowing the user to configure a multiple of standard deviations away from the mean to be a good corner candidate. So the default is 2, so 2 standard deviations away from the mean. I consider that to be a good corner candidate. And then you can pass those collection of vectors of 2D points to the Bezier fitting code, and it will then result in some piecewise Beziers, a collection of them being output, which you can then use to create new geometry somewhere in the scene. I also have a look at the control points that have been created, and if they are more or less collinear. The default is for control points to not be related in any way, but if the control points are more or less collinear, then I set up their type to be collinear, and the same if their length is more or less the same. I set up their type to be matching lengths as well. So if I have a look at this, so obviously I've been satisfied that those two control points were more or less collinear when created, so I've set up their type accordingly, and so they'll always be collinear unless the user changes their type. Where the new geometry is placed in the scene will impact on how it's used. At the moment it's set up to be the root of the scene. So if I do another freehand drawing, it's created something else at the root of the scene. But there are a number of different ways it can be configured, and I'll show you those now. So we've now got the same tool configured to create a child of the current selection. So if I create a round rect, that's selected, and now do a freehand drawing, we can see the stroke and the body colours of the child geometry is the same as the round rect parent, so it's a bit difficult to see, but you can see that it is a child because it's clipped by the geometry of its parent. The tool is now configured to create a mask. So if we create a shape and again do some freehand drawing, you can see that the new geometry data, the body and the stroke of the new geometry data is being used to impact on the opacity of its parent because it's a mask. This mask will also impact on any children of this parent round rect. So if you wanted to just impact on the opacity of the owner of your new freehand content, you could set up the tool to create an opacity fill instead of a mask. So if we place, let's place a dib. And we've configured the freehand tool to create an opacity fill. So if we draw something freehand, we can see the body and the stroke of the new geometry has been associated with the dib as an opacity fill, and you can see it's impacting on its opacity. Opacity fills don't impact on the child of the owner, so that's where they differ from masks. If you've got some existing geometry in the scene, the tool can also be configured to append to that geometry. So if let's draw a round rect and then select the freehand tool, which has been configured to append placement to existing geometry. And if we draw, we can see that no new nodes in the render tree have been created, but an existing geometry node has been appended to with additional Beziers. If we deselect that and keep the tool configured to append geometry, we could, let's draw something, and then we can append to that because a node is selected. So if we select some geometry, have a node selected, and have the tool configured to be in append mode, you can just hover over the node you want to add to and start drawing from there, which will give us this effect. The tool also supports clicking rather than dragging, so you could click to create line segments, and also you can draw. If you want to append, you don't have to hover over a node you want to start drawing from. It needs to be selected though, and you can start drawing from here and you'll get that effect. There are a few other configurations that can be used with this tool that will impact on where the new geometry is placed. They are the body fill or the stroke fill of existing geometry, or the body opacity and the stroke opacity of existing geometry. Those four have been seen and described previously in other videos. But one other interesting configuration is to smooth the input data. So just to reiterate, we take the raw 2D point data, remove collinear, coincident points, find corner candidates, and then process each range that is delimited by corner positions and fit Beziers to them. But one other way to try and get the best results possible from the graphics gems Bezier fitting code is to smooth the 2D freehand points as they're being drawn by the user. So I've configured the tool up to do that now, and if we start drawing, you can see it's a lot smoother. The impact of this extra smoothness is fewer Beziers were needed to fit the point data, fewer corners were in the point data, and it gives a better, in my opinion, a better end result. This is done, the smoothing is done by having a user configurable smoothing window. The size is configurable by the user, and this window will track the freehand drawing as the user is doing the drawing, and average the point data within that window and use that average to be the 2D position for that part of the freehand drawing. And that is the new freehand placement tool.